Okay, so is it recording? Okay, it's recording. Okay, so I'm gonna be explaining a certain question in a past paper. I'm just gonna open it right now. Let me open it. Ah, so it is question 11 from from the summer of 2019, time zone 2. It's paper 2 as well, and it's worth 9 points. It is. I tried this before and it's kind of confusing, but I'll explain it as best as I can. As I can. So, first of all, the velocity v meter per second of a particle traveling in a straight line t seconds after passing through a fixed point O is given by v equals to 4 over open bracket t plus 1 close bracket to the power of 3. So the first sub question asks you to explain why the direction of the motion of the particle never changes. I'm just gonna be making it red, so the more it will look important because it is important. So when it comes to math, their way of explaining, like, in sciences where you have to write words and all that, in math you don't do that. It's a waste of time and it's only 1 point. So how will you some explain with only 1 point? Well, it's simple. So explain why the directional motion of the particle never changes. So when I first did this question, it is really confusing. I have no idea why, and I put in words, which is not really a good idea. And when I check the mark scheme, it is really in it shows an answer that I don't expect. But at first I don't understand how to do it. But as I see the question again and again, I think it's trying. I think I figure out how to explain this. So to do this question, you don't really need to show working. So, but let's start with t equals to 0. Let's substitute t equals to 0 into this equation. So if t equals to 0, like let's put it this 0 plus 1 to the power of 3, it is 1 to the power of 3. So this makes v equals to 4 when t equals to 0. Now let's change it up a bit. Let's put 1 instead. So 1 and 1 plus 1 is 2. 2 to the power of 3 is 8. So 4 over 8 is 1 over 2. Now we do this with 2 now. And 2 plus 1, 3. 3 to the power of 3 is 27. 4 over 27. Are you getting the pattern? Uh, are you getting the pattern? Let me just write it here for you to see the pattern. Okay. T equals, I'm just gonna put 1, and this would be 1 over 2, I believe. And it's 2, it's 4 over 27. I'm not gonna write, I don't really have any space, so but it's 4 over 27. I'm just gonna write over this question because I'm gonna be deleting this later on since this working is supposed to not really exist. Let me fix the 4 bit. Okay. So t equals to 0, v equals to 4, 1 is 1 over 2, 2 is 4 over 27. You see the pattern. So if you don't, I'm gonna just state it to you. Do you notice that each value is positive? Like if you're not convinced, you can try putting t equals to 3, t equals to 4, and no matter what number you put as t, what value you put as t, it will always be positive and it will never reach 0. So if this was a graph, let me draw a graph, it will be something like this. It's not reaching 0, so let me fix that. So it is always, it's decreasing, yes, but it never touches 0. It's quite slight. It never touches 0. So why does the direction, and since it always stays positive, so why the direction and the motion of the particle never changes? That is because, let me delete this because I don't really like numbers on the question. V is more than 0. This is the answer that you're supposed to choose. Or if, however, you can, this is the answer. However, this is an answer that's befitting of the situation. If it's negative, for example, then you put V is less than 0. But in this case, it is positive, so V is more than 0. However, if you want a clearer like a more sure answer, it would be V is never equal to 0. This is the answer. V is more than 0 or V is not equal to 0. However, I believe this is better since since this one could mean it's negative, positive, so it's better to just use this as your answer. Okay, showing all your working, find the acceleration of the particle when t equals to 5. So, so when you want to find acceleration, acceleration is the derivative of velocity. And okay, now looking back here, let me just delete this. The equation for velocity is v equals to 4 over open bracket t plus 1 close bracket to the power of 3. You can also write v as 4 t plus 1. Oh, looks like 2. 1 to the power of, let's put in this here, negative 3. Since it's a fraction, the power is in the fraction mode, is over in the denominator. It means this is negative 3 if we put it in as the numerator. So what is the derivative of this equation? Well, it's pretty simple. A equals to, I'm going to explain this step by step. First, you bring down the power. You bring this power to the front. You bring this power to the front. So negative 3 times 4. I'm just going to write this. So if k x plus n over, wait, actually better if we call this, let's call this y, to the power of n, or we just call it m for good sake. K to the power of m times n, m, it refers to an equation, so and it will be equal to, and this will turn into n times k and k m n minus 1 and times m, the derivative of m. That is the equation for this for now. Of course, you can do the substitution. Is it called the substitution rule? Like the rule where you do where you put the derivative of the derivative of this. You can do this, but you can use this equation, you which you can use this equation where the denominator is v and the numerator is u. However, I prefer to use this equation since it's only a simple one, and the working is the this is much shorter in comparison to this. So I'll be using this instead. So we have -3 times 4, t plus 1. And -3 minus 1 is, -3 minus 1 is -4. Don't actually put +1. It's a common silly mistake. I do that sometimes, so be careful. And the derivative of t plus 1 is 1. So it becomes -12 t plus, or if let's just put it in the fraction in positive integers. So -12 over t plus 1 bracket. Oh, my brackets. Oh gosh, it's really hard to draw with trackpad 4. I wish I have a tablet. Okay, it's not really the best looking one, but it works. If it works, it works. Let's put this a little bit down. So this is the equation for acceleration. Don't put plus c because it's not integration. So this is your equation now. But then we don't stop here. We're asked to find the acceleration of the particle when t equals to 5 seconds. So we substitute. So it's really simple. We just substitute 5 into this. So when t equals to 5, so when t equals to 5, I'm not going to put t equals to 5 because I'm running out of space. It will be 12. 5 plus 1 is 6, so we have 6 to the power of 4. And using the calculator, 6 to the power of 4 is, and 6 to the power of 4 is 1,296. Oh my. And this means -12 divided by 1,296 is -1 over 108 meter per second square. I'm just going to put it in this since it's put it like they put it meter per second. This is also the same as meter per second, but they put it in like negative integers. So I'm also going to put it in negative integers. So meter per second square. I'm not gonna turn this into 3 significant figures because that would hinder the accuracy, and it's okay if you just use this answer because it is the answer. It's the most accurate. This is the accurate answer. If you rather than rounding off, at least there's a fraction. So for the next sub question, find an expression for the displacement of the particle from O after t seconds. Let me drink some water first. Okay, so displacement is the integral of velocity. I'm gonna just put dt. is the integral of velocity. This is not really obvious. So if you want to find the integral of v, we basically find the integral of why is it suddenly turns? So the integral of v is this equation. We just use this equation because this equation is just too complicated. If you want to like, you know, we're gonna just use this equation because it's this version of the equation because it's much simpler to it has much simpler working instead of like doing this as a fraction. So let's do this. Okay. So to know about this integrals, so we have k. I'm just gonna put this k, and again m refers to the equation m. It's over k is over, and then and n plus 1 over n plus 1 over n plus 1 times the derivative of m. I'm just gonna put it like that. So this is the equation. I'm just gonna turn this into just one. So following that equation, so we know that's 4. So it's 4t plus 1 negative 2, because negative 3 plus 1 is negative 2. I'm not going to do something that's such simple calculation there. And so we have negative 2 as our denominator. Of course, we shouldn't forget about derivatives, so negative 2 times 1. And negative 2 times 1 is negative 2, so 4 times negative 2, it would come negative 2 over t plus 1. Let me to the power of 2. However, it's not over yet. We have c. So, of course, we do not stop here. So we have to find c. So how to find c? Well, we basically find in O's. When it's O, it is so point O is meaning it is t equals to 0 seconds. So when t equals, so we basically substitute t equals to 0. So when t equals to 0, what do we get? Wait, no, it's not t equals to 0, it's s equals to 0. And t equals also equal to 0. O means s equals to 0 and t equals to 0. Don't forget about that. So basically we just substitute. I'm just going to be using this equation because I don't want to like rewrite it, and plus I'm running out of space. So 0, negative 2, let's switch this into 0. 0 plus 1, 1 square, 1, and it's 1, negative 2. So 0, negative 2. And when you move negative 2 to here, it becomes 2. So c equals to 2. So c equals to 2. I'm not going to write it since it will be a lot of space and I don't really have enough space. So the answer for S, so the expression is negative 2 over t plus 1 plus 1 plus 2. That is our expression. Okay, now on to the final sub-question. Find the distance traveled by the particle in the 4th second. So what is the distance? Now we have to pay attention. Distance. I'm just gonna have distance in the 4th second. Let me just, okay. It's, take note that it says distance and not displacement. So if you know science, displacement in distance is totally different things. It applies the same to math. I'm just going to do this. So displacement is how much, like for example, we have a line here and we have 2 dots. Actually, maybe 3. So we have here, here, and here. So let's, for example, that I start from this first dot and we move from this dot to here. However, we decide to turn back and go here. So it becomes like this. And boop, boop. I'm just gonna be putting this here. So displacement is basically we only count this part. Or if you want the other meaning, it means we use this distance and minus it with this distance. Because technically you basically move back. And if you move back, you technically decrease the distance. So you basically displace only this amount of distance. However, if you're talking about distance, like this is displacement. If you're talking about distance, you add this one with this one. So inside, if this is science, I would say that displacement has direction. So there's a plus and minus. So if you add like what I just shown earlier with like plus and then there's a minus. So, and it basically cancels some numbers. For example, there was a 300 meters per second, you go back 200 meters per second, then there's 300 minus 200, 100 meters per second. That's the displacement. However, in distance, like if you go 300 meters per second and go back 200 meters per second, you use 300 plus 200. It's 500 meters per second because there's no direction in distance. So let's find the distance. So when let's first of all, we substitute 0. And when we have 0, s equals to 0. Okay. How about if it's 1? So when it's 1, we substitute 1 to this equation. I'm not writing it because it's a pain to do so. But just know that we're going to be using this displacement equation. So 1 add substitute to this part. Of course, you have to write the equation here, but I'm not writing it for the sake of saving space and my hands. 1 plus 2 plus 1 plus 1 is 2. 2 squared equals to 4. Negative 2 over 4 is negative half. Plus 2 is 3 over 2. So when t equals to 1, s will be equal to 1.5 meters. I'm just going to put 0 meters. 0 meters. 1.5 meters. Now, how about if t equals to 2? Let's start again. We do the same thing. 2 plus 1, 3. 3 squared, 9. Negative 2 over 9 plus 2. And that would be negative 2 over 9 plus 2. That will be 16 over 9 meters. I'm putting in a fraction because it is a pain to do so. But if you want to put in, it is, by the way, this is higher than 1.5 meters. It is, if you want to round it off, it is 1.78 meters to three significant figures, but I recommend you don't round it off first. You keep this to maintain accuracy in your answers. Now t equals to 3 seconds, 3 plus 1, 4, 4 squared, 16, negative 2 over 16 with negative 1 over 8, and that would be 15 over 8 meters. Negative 15 over 8 meters is higher than this. It's 1.875 meters. So right now it's going up. It's still going up. So S equals to, now when t equals to 4 seconds, 4 plus 1, 5, 5 squared, 25, negative 2 over 25 plus 2, it would be, let me just, 2 minus 25. It will be 1.92 meters. Now, coincidentally, it's all in descending order. It's all in ascending order. So we can basically say that this is our answer because it's ascending. And so the difference here is 1.5 meters. The difference here is 2 and then we move 1.7, and when it's t equals to 2, it's 1.77 meters. 16 over 9 meters. We don't go back. So we don't really need to count the difference between this since we move forward. So this is the distance that we travel. And it continues, the displacement continues ascending. So in the end, this is our answer. It is finally at 1.92 meters. So what is the distance? It is from here to here. So our answer would be 1.92 meters. Of course, if it goes back here and forth, you have to find the difference between the two values so you can add it as distance. Because, but right now this coincidentally they are all ascending, so it's safe to say that this is the distance traveled because there's no going back and forth. It's all moving forward like this. There is no here or there. It's all just moving forward. So this is our distance. So this is the final question, I believe. Yes, it is the final question. And this is the answer as stated in the mark scheme. I checked it myself way before I started this video. It is the answer in the mark scheme. So don't worry, it is okay. It's all 9. We get all 9 points. It's safe to say we all get 9 points. So that is it for this meeting, this video. I'm not gonna do like and subscribe. I wish I could but then I'm not a VTuber. So let's stop this. Okay. Bye.